Okay, so we're going to start our unit on quadratic functions. And the first thing we're going to do is learn how to transform quadratic functions. Okay, so that is our learning target. Of course, when you think of transforming something, the first thing that comes to my mind is transformers. And so remember, when you transform, that means to change. And so really what we're going to do is change just kind of what we know about quadratic functions, basic ones, and change them. How can we change them around? Just like transformers change from a robot to like a car or whatever, okay? So what is a quadratic function, first of all, and then how do we transform them? So first, we need to know what a quadratic function is and how they can look. Okay, so when we look at their equations, they really have two forms that we're going to see. And you'll notice a couple of different things here about that. It says a quadratic function is a function that can be written either in this form right here, this, let's see, this is called standard form, okay? And it's y equals ax squared plus bx plus c. The key thing here is that squared, okay? That x squared. Quadratic functions are going to have a degree of 2, meaning the highest exponent you'll see is 2. But it has to have that term. It might not have these. These 2's don't necessarily have to be there, but it has to have that x squared in there, and it has to be the highest degree term. Okay, so that's one of the things you're going to look for. And then the other form is called vertex form, and this looks a little bit different, and there's a reason for that. It gives us the vertex, which we'll talk more about. But notice you'll see this squared in here once again. And they do look a little bit different, but if they look like one of these two things, it's a quadratic function. Okay, that's the important thing to kind of keep in mind. So you really want to focus on, is it standard form, vertex form, and then what does that mean? And we'll talk more about that, but that's really the first way you can identify from an equation is, does it look like either of those two things? Okay, so now quadratic functions, not only from their equations, but their graphs. What do they look like? These have a curved sort of a U shape or maybe an upside down U shape. So you'll notice this one here on the left, kind of a U shape, and then this one on the right sort of flipped upside down and facing down. So these are called parabolas. And all quadratic functions, when you graph them, form a parabola. So you know what it's going to look like. It's going to look something like one of those two things. Now, there are some important parts of quadratic functions, of parabolas, when you graph them. So these are some things that we kind of are going to talk about in this unit quite a bit. You have a line of symmetry. It's called the axis of symmetry. You know, axis means line. So it's just a line of symmetry that here is highlighted in orange. This right here just cuts that graph into two symmetrical halves. Okay, it always passes through a very important point called the vertex. Okay, this is our vertex. This right here is going to be your highest or lowest point on the parabola. In this case, it's the lowest point, but you'll notice here it's kind of highlighted. It says vertex of a parabola, the highest or the lowest or the highest point. Okay, that's a really important point. Your x-intercepts are also known as your solutions. Those are the ones in red, and you know what a y-intercept. So you guys are familiar with those, but these are the pieces that we will talk about throughout the unit. And one of the first things we'll talk about is the vertex. Okay. Again, highest or lowest point. Okay, and that will come up quite a bit. So parabolas and the vertex. Okay, so when you graph them, it should look like a parabola. Now you can use your graphing calculator to help you do this. And I'm going to show you, you'll be given a graph, and a lot of times you'll have to put that onto, plot these points and whatnot. So the easiest way to do this is to use your graphing calculator to help that process. Because we have a graphing calculator, may as well use it. So I guess the first thing you want to do is you've got this quadratic function x squared minus 4x plus 3. Okay, so how do we graph that? Well, you could type in and try to find some different points, but the easiest thing is to use our graphing calculator. Let me show you how this works. So if I open up my MCA calculator, I'm going to do that. Now, I've been having some problems when my MCA calculator, I'll go to this and it'll just be blank. Okay, if you're having the same issue, there's some variety of things you could do, but usually one of the easiest thing is, you see that like compass-like dial in the upper right, all the way into the upper right. If I tap that thing, it's like a circle with a little diamond in the middle. If I tap that, often it'll just send it to Safari, and then it seems to work just fine. So then I just press start a couple of times. I don't know why it's doing that. Hopefully they fix it, but just do that if you are having the same issues. Okay, so now I'm back here, and I'm just gonna, I want to graph here. So I'm gonna go to y equals in the upper left, and I'm gonna type in my function. So y equals x squared. So remember, x is right here. Squared is on the left, right in the middle there. So that's how you square that. Okay, and then I want minus 4x plus 3. Now, I'm going to press graph. Okay, I know it needs to look like this. Okay, now notice that is a parabola. If you press graph and it doesn't look like a parabola, you type something in wrong. So just go back and fix that and check your work, because it always should look like a parabola. Okay, now I actually want the numbers here, the coordinates of these points, so I can plot them on my graph. So I'm going to go to my table. Now you'll notice, right, the red button says graph, but this right above that it says table in blue. So I'm going to hit second and then graph again, so I get the table. Okay, and you get some x and y coordinates. These are all the points that show up on the graph. Okay, now I am going to write down all the ones that will fit on my graph. Now if you looked at my graph before here, my graph only goes up to 10 and negative 10 on both the x and y axis. So really, what I want to do is make an xy table, and I'm just going to write down all the points that will fit on my graph. So let's take a look. So now you may have to use the up and down arrow keys, so I'm going to scroll up here and see what I can fit. Now notice negative 324 is not going to fit. Negative 215 is not going to fit. So negative 1, 8 will fit. So I'm going to write that. Negative 1, 8, and 0, 3. Zero, 3. Okay, and what else was there? Okay, 1, 0. 2, negative 1. Okay, again, I'm writing down all the ones that will fit on my graph. Looks like 3, 0, 4, 3, and 5, 8. 3, 0, 4, 3, and 5, negative 8. So now, sometimes you'll only have a few points that will fit. This one I have a number of them that fit, so I'm gonna plot all these points, right? So I have negative 1, 8, 0, 3, 1, 0, 2, negative 1, 3, 0, 4, 3, and 5. Oh, maybe that's 5, 8. Maybe I looked at that wrong. Yeah, that's 5, 8. Okay. So I wrote that wrong. Okay, remember it should look like a parabola, so that's kind of how I knew that that wasn't quite right. That would have been off. 5, 8. Okay, so now there it is. Now I just need to connect these points with a smooth curve, not a V. It's a U shape and should have curve. Okay, so I'm going to try to do that as best I can. And then this continues to go up, so I'm going to put arrowheads on there. Okay, so again, smooth curve. Don't just do this. That's not a parabola. Okay, that's actually something else. It's actually an absolute value function. We don't want to do that. Okay, but these are the points that I can plot, and that's how you use your graphing calculator to help you do that. Okay, all right, so now I've got that. Cool. I've just graphed it. I know it's a parabola. Again, if you want to check on this, you could go back to graph and see, does it look like that? Yeah. Looks pretty similar. Cool. I've got it. All right. Now, the most basic quadratic function is y equals x squared. And what does it look like? It looks like this. It touches the origin right here. Okay, right here. That's the origin. And it goes up on both sides. The y-axis is the axis of symmetry. It cuts it right in half. But that's the most basic quadratic function. And it's called a parent function. The reason for that is all quadratic functions are transformations of this, changes of this function. Okay, so everything else is really a baby of this parent function. Okay, so we just modify the parent function and we can get all these different kinds of quadratic functions. Okay, so that's why it's called a parent function. Okay, now what I'd like to do is go over a couple of different things. The first thing we're going to talk about is transformations when looking at vertex form. Okay, so again, at the beginning, vertex form was f of x, or remember this is the same as y. Okay, so you could replace that with a y, equals a times the quantity x minus h squared plus k. Okay, so that's what we had at the very beginning of this lesson. So really what I want to focus on to begin with is this h value, and what does that do? Okay, so I kind of wrote that over here on the left. What does h do? Okay, so that's what I want to look at. And we're going to compare it to the parent function, the regular one, just y equals x squared. So the first one I wrote here is y equals x plus 4 quantity squared. Okay, so what does that plus 4 do? Well, what might you think it does? So maybe to make a prediction about what you think that might do to the graph. And then we're going to look at it. So I'm going to go to my graphing calculator. Okay, so here I'm actually just going to type in x squared. That's my parent function. And then that one's going to be graphed in blue. And then in the second one, I'm going to put x plus 4 squared. Okay, so that's my second one. That will be graphed in red. So now I'm going to go graph. So what happened? Now you'll notice the original parent function blue, and then what happened? This whole function, or the quadratic function, got slid to the left 4 units. Okay? Now does that make sense based on what we have here? So this it's a little backwards from what I would have thought, right? It says plus 4. So when I think plus 4, I would normally think that would move that to the right 4 units. But it doesn't. It actually moves it left 4 units. Okay, so that's sort of backwards of what I might think. Okay, so then let's try this other one and see how that works. Okay, so I'm going to go here, leave that parent function in here, and in this one I'm just going to type x minus 3 squared. Okay, so now what happens here? Okay, there's our parent function. Now this time it slid it to the right 3 units. Okay, so let's go back. Once again, when I see minus 3, that I would think left. But it doesn't. What happens is it actually moves it to the right 3 units. So that, again, opposite of what I might think. And here's why that is. You'll notice the vertex form actually already has this minus in there. So that is what creates the opposite of what you might think. So really, what does the h value do? It moves the graph left or right, and actually maybe I'll just put left or right, and then really what is it? It's opposite of what we might think. Okay, so that's kind of an important thing to kind of keep in mind, and we'll touch on that again. All right, one last thing I want to go over today, and that is, what does the k value do, this one at the end? Okay, now notice the k, the h1 was easy to identify because it's inside the parentheses and it's being squared. Okay, now the k value is not being squared, nothing going on there. So you'll notice when I wrote these here, h hasn't been, there's nothing happening with h, only this k. So what does this do? Okay, now let's take a look. Okay, so once again, I'm going to leave that one in here. So now x squared plus 2 graph. Okay, what had happened? It just moved it up. You can see there, up 2 units. Okay, so what does this do? Just up 2 units. Now, when you see plus 2, you would think, oh yeah, that's going to move it up. So this one's is normal. This is more like what you might think. So this one says on the right, y equals x squared minus 5. This one will move it down 5 units, and just like you would expect. So k value moves this up or down, and this one is normal. Okay, no weird things going on. And again, notice the reason for that is because it's a plus k there, and that's going to be normal. If that were minus, then that would be opposite then. So that's really it. Okay, so tomorrow we're going to talk a little bit about the a value, and then how we put all these together and describe all the transformations that have been happening. Okay, I hope this makes sense. Have a good one. See ya.